atomic radius. Trend within periods. In general, there is a decrease in atomic radii as you move from left to right across the period. This trend is illustrated in the figure 12 as we will see. It is caused by the increasing positive charge in the nucleus and the fact that principal energy level within a period remains the same. So, because the positive charge increasing in the nucleus, that's why, and as we know that the fact that principal energy level within a period remains the same, so that's why we have a decrease in atomic radii from left to right. Each successive element has one additional proton and electron, and each additional electron is added to orbital corresponding to the same principal energy level. Moving across a period, no additional electrons come between the valence electron and the nucleus. Thus, the valence electrons are not shielded from the increasing nuclear charge, which pulls the outermost electrons closer to the nucleus. So, this is the periodic table, this figure 12. As you see here, as you go from left to right with the same period, for example, period 2, as you go from left to right from lithium, Pe, BeP, the size of the atom will decrease. So the radius or the atomic radius is decreasing too. So as you see, as you go from left to right in the same period, the size decrease, so the atomic radius decrease, so the atomic radii of the presentative elements given in and these numbers, as you see here, 152, 112, these numbers are given in by kilometers, which is 10 to the power of picometers. Picometers, which is 10 to the power of negative 12 meter. Okay. Atomic radius generally increases as you move down as in a group. So now what about as you going as at the same group? So in the same period, decrease as you go from left to right in the period. On the group, it increase as you go from up to down, so it increases as you go, as you move down on a group. As you see, the atom size is what is increasing as you go down, so that's why also the atomic radius is increasing too. This is about the trend within groups. So again, atomic radius on the period, it is decreasing as you go from left to right within a period. Adding one proton to a hydrogen nucleus change the identity of the element to helium, for example. So as we know that hydrogen, it has only one electron. So if you add another one electron to the hydrogen, it will what? Will change the identity of the hydrogen to what? It will be from one electron to two electron. Which element has two electrons? Helium. So if you add one extra electron to the hydrogen, this will change the hydrogen from hydrogen to helium. The increased attraction between the two protons and two electrons causes helium's radius to be smaller than hydrogen. So as you see here, so as you add another electron to the hydrogen, it will change to a helium, and as you see also, this causes the helium's radius to be smaller than the hydrogen. Now, discuss how the fact principal energy level remains the same within a period. Explain the decrease in the atomic radii across the period. So as we know, we said that the nuclear charge increases while electrons are being added to the same energy level because the amount of shielding remains the same. The nucleus pulls more strongly on the valence electrons, which decreases the radius. Okay, so again, as you move down the group, the nuclear charge increase and electrons are added to orbitals corresponding to successively higher principal energy level. So as you go down to the group, the nuclear charge will what? Will increase because and electrons are adding to the orbital, okay, because the more electrons are adding to the orbital corresponding to successively higher, because we have higher principal energy level as you go down on the group. So however, the increasing nuclear charge does not pull outer electrons toward the nucleus to make the atom smaller. This is because as you move down a group, the outermost orbital increases in size along with the increasing principal energy level. Thus, the atom becomes larger. The larger orbital means that the outer electrons are farther from the nucleus. The increased distance offsets the pull of the increased nuclear charge. Also, as additional orbital between the nucleus and the outer electrons are occupied, the inner electrons shield the outer electrons from the pull of the positive charge in the nucleus. This is known as what? Shielding effect. So this is the shielding effect. Moving down a group, electrons are added to higher principal energy level. As I said that these electrons are farther from the nucleus and are shielded by inner electrons from the nucleus pull. So for example, the outer 2s electron in lithium is shielded only by inner 1s, while the outer 3s electron in sodium is shielded by inner 2s, 2p and 1s electrons. So as you see here, these are the inner electrons and this is the outer electron. Also these are the inner electrons and this is the outer electron. So the outer 2s in lithium is shielded by what? Only by 1s, which is we have in 1s 2 electrons, as we know. So it is shielded by only this orbital. But in sodium, this outer electron it's shielded by 1s and 2p. That's why these shielded electrons that's why this outer most electron will not be attracted to the nucleus because of these shielded electrons. Okay, in summary, across the periodic table, atomic radii generally decrease moving from left to right in a period and generally increase moving down a group. So again, as you go from left to right across a period, the atomic radius decreasing, and as you go down it will increase. Now explain why calcium, for example, has a greater atomic radius than magnesium and its outer electrons are in orbitals corresponding to higher energy level. Okay, now we have another questions. Please solve them. Use your knowledge of a group and periodic trend in atomic radii to rank the elements in each set in order of decreasing atomic radii. So here you have to arrange these elements according to the decreasing in atomic radii. Use the periodic table to solve them. Okay, and these are the answer.